Friends, I came across this unique object recently. If I take it closer to objects like U-clips, pins, coins, these get attracted. If I repeat the same with marble, plastic ruler, paper or pencil, nothing happens. So can you guess this unique object? Yes, it is called magnet. You might have played with it as well. You must have noticed door of fridge getting closed on its own, pins sticking to the pin holder, cupboard doors with a click, or even purse flap sticking to other side. Magnetic materials are used in credit cards, hard disks, audio and video tape to store information. These are some of the applications of magnet we see daily. There are other devices around which have magnet, but you cannot see them. For example, telephone, doorbell, television, mixer in the kitchen and speaker. Let us remove the cover from the speaker. You see a large round magnet with a hole in the middle. This is similar to the magnet we saw earlier. Now you know that some materials are attracted towards magnet while others are not attracted. Can you get a magnet and find out which objects at your home are attracted by magnet and which one are not? Make a list and share it with your friends and teacher. The objects attracted by magnet are called magnetic materials. Iron, nickel and cobalt are the magnetic substances. Objects made up of these materials are attracted by a magnet. Also, magnetic materials can be magnetized, or we can say that magnetic materials can be converted into magnets. Those materials which are not attracted by a magnet are called non-magnetic materials. All the substances other than iron, nickel and cobalt are non-magnetic substances. For example, plastic, rubber are non-magnetic materials. Non-magnetic substances cannot be magnetized. The word magnetism comes from the ancient Greek city of Magnesia. There was a shepherd who was said to have found that iron nails in his sandals stuck to the certain stones. These stones must have been made up of the magnetic material magnetite. Magnet we found in the speaker has round. Magnets come in different shapes and sizes too. Horseshoe magnet, bar magnet, ring magnet, cylindrical magnets are some of the examples of magnets. If I bring these two magnets closer to bunch of pins and lift it, what do you observe? This magnet has attracted more pins than this one. Magnets have different strength or power as well. If I have to move this car, I have to touch it and pull it with my fingers. If I bring this magnet and pull forward, what is causing this mysterious pull? Think about it. All magnets have some force which is not visible. This force is called non-contact force. But with the help of iron filings, we can visualize it. We will do this later. If I place this nail near the steel ball, nothing happens. When I bring a strong magnet near the nail, it becomes a magnet itself. Steel ball will leave the nail as soon as I take away strong magnet. Iron does not keep the magnetism permanently. This is another bar magnet. Let us take this magnet closer to other magnet. What happened? Other magnet is attracted towards this magnet. Now let us rotate it and take the other end closer to the magnet. Did it attract this time also? No. Instead of attracting, it pushed the other magnet away. Looks like two ends of the magnet are behaving differently. I will mark it with a dot. Let me take a thread and tie the magnet with it. If I suspend it and rotate it freely, the end marked with the dot always seems to settle in one particular direction. Can you guess what that direction is? Ancient people knew that naturally occurring piece of magnetite sometimes settled in north-south direction and used it as navigation aid in the past. It should be noted that magnetite is not always magnetic. Instead of hanging it by a thread, they used to keep it on the wood and float the wood in water kept in the container. Let us keep this piece of magnetite on the wooden block and float it in the water. It aligns itself in north-south direction. Let's float our bar magnet as well to see if it also settles in north-south direction. Yes, it did. All the magnets, natural or man-made, they possess this unique property. Can you do this activity in your classroom or at home? Of course, you have to know the north and south directions of your class. Coming back to our bar magnet, we will call this end marked with dot as north pole as it is pointing in the north direction, and the other end south pole as it is pointing in south direction. For convenience, some magnets are marked with capital N for north pole and later capital S for south pole. If I bring two ends of the magnet marked with N, that is north pole, they repel each other. Same is true with two ends marked with capital S. We can say that similar poles repel each other. If I bring opposite poles, north pole marked as N and south pole marked as S, they attract each other. We can say that opposite poles attract each other. If I hang one magnet, why does it always align itself in north-south direction and not in east-west direction? Think about it. There must be something else which is acting like a magnet. What is that? Earth is a giant magnet. It has its own magnetic power as well. When we hang our bar magnet, it is attracted by Earth's magnetic pole. Conventionally, that end of the magnet which is pointing in north direction is called north pole. You cannot see magnetic field of Earth, but you can see its effect with the help of magnetic compass. Compass contains a tiny magnet that can swing around freely. One end always points to Earth's north pole, while the other points to south pole. Challenge: is rust magnetic in nature? We know that magnets are all around us. Some objects are attracted by magnet while others are not. All magnets have two poles, north pole and south pole. Our planet Earth itself is a giant magnet. Find out more information about magnet on the internet.